Hello, my name is Brian Stewart. I major in chemical engineering.
Hi, my name is Kevin Horton, and I'm majoring in electrical engineering.
My name is David Morgan, and I'm also majoring in chemical engineering, and this is our proposed hydroelectric power plant.
We began with our problem statement, and it was to create a unique, low-cost, durable, but still environmentally versatile and friendly renewable energy source in a condensed size, however still scalable to meet the energy needs of the city and become a leader in this field.
The goals laid out for this project is to produce a portable, reliable, and cost-effective power supply that will either contribute or conform with the aesthetics of the surrounding area.
Now, our top design goals that we set for ourselves were we wanted to make this a reliable power source, something that would use a renewable energy source but make it cost-effective and efficient. However, we also know that this is going into a public space, and we want to make a unique, aesthetically pleasing design to it as well.
So our proposed design at first, and still is we need it to work everywhere. Anywhere and everywhere. This needs to be able to be deployed around the world. It's not site specific. So we also needed it to be completely portable. And able to be disassembled and reassembled without any technical knowledge. That includes removing the top. In this next photo, you'll see that it actually removes the whole top. This allows for easy maintenance inside of the whole central hub. And the complete top comes off and the complete hull comes off at the base. It's completely disassemblable. We also needed all-in-one power. We needed a certain system that didn't have anything that was external. We needed it all inside. That's where we came up with the idea with the turbine. No other items required. We have a turbine combined with battery power. The next slide shows exactly how we were doing these batteries. It's a chemical reaction inside the batteries that creates the power, and this is used as a backup/storage system for the hydropower electric that we're getting from the turbine. On the next slide, you'll see that we decided with a 3D printed turbine. The benefits of a 3D printed turbine allow it to be molded and able to change due to any kind of environment changes that it needs. So it's not one static design. It's able to be changed into a whole bunch of different ones. On the next slide, you'll see that it still maintains that aesthetic design. So it still looks nice, and I wouldn't mind having this in my city center either. On the next slide, you'll see that each one of these parts are able to be reproduced by any company out there. It doesn't require a certain company to make these parts. These parts would be open source. Anybody could download and print these specific parts. The best part is it's biodegradable. So every part of this machine, power plant, is completely biodegradable. The only part that's not is the motor.
Now, our justification for our design started with it not only met the design requirements we set for ourselves, but also those of the client. It was low cost, it was portable, self-sustaining, and aesthetically pleasing. And also, overall, it was more efficient than our other designs. The turbine itself was, with the horizontal design, produced or showed less friction, and therefore was a more viable option than its water wheel counterpart. And not only that, it met all of the criteria that we set out for ourselves. It was a distillation of all our ideas to this point, and came out to be the best products that we could make.
Our final budget is $39.20. That leaves us about $10.80 under budget, 22%, about a quarter of our original budget forecast for this project.
So our design matrix, you can see three different ideas. We have the original pitchback, and then also the brush shop with balsa wood. Both of these are a vertical wheel. That's more of a less used technology in this day and age. The new modern technology is a turbine. It's going to be a horizontal turbine that provides more power, less friction, and able to be maneuvered around in different areas. And the design matrix, it was really lopsided after we got the 3D printed Francis turbine build, and it just completely beat out all the other lesser, older models.
Water was chosen because of the easiness in which we were able to mathematically model the flow and power of the stream, allowing us to make more predictive calculations of what we could expect from the stream itself. Here we have the graphic model of our power curve. The operational speed we found to be around the area of 920 RPMs, which brings us more towards the high torque area of the power curve. The reason why this is because we've foregone the gears in order to reduce moving parts. More moving parts, more things that are likely to be broken.
And our score prediction on here was the performance metric, the penalties and bonus points, the three main points. We didn't have too many penalties that we could predict, but we got the power delivered, the community integration inside just with our build. The craftsman and the design is very unique. It's all in one. That was pretty much our main topic. The bonus points would have been the creativity and then the additional markets. This could be expanded into a whole bunch of different markets, able to be used and utilized everywhere else. And then also the craftsmanship.
All right, thanks guys. So, and also do I have your permission that the doc posted on YouTube?
My lawyer will have a doc with you. Yes.
All right, thank you.